Okay, so question number 2. 2a, how many valence electrons are assigned to oxygen when determining the formal charge in the ionic compound sodium methoxide? And part B, which substituent has higher priority? Okay, so this is a 2-part question. Okay, so this is sodium methoxide. And it might be more helpful to show how how to answer this question just by drawing out its Lewis structure first. So to draw out the Lewis structure of sodium methoxide, we need to calculate the total number of valence electrons. So sodium has 1, oxygen has 6, carbon has 4, and hydrogen also has 1. But since we have 3 hydrogen atoms, we multiply this by 3. Okay, so now we can kind of draw a general skeletal structure. So carbon has the 3 single bonds to the hydrogens, and the sodium and the oxygen are bonded together through an ionic bond. And if we count out how many electrons we've drawn so far, where each bond contains 2 bonding electrons, then you can see that we only have 10 out of the 14 total valence electrons in this structure. So for the remaining 4, we'll put them on our oxygen. Okay, so now let's calculate the formal charge of the oxygen. So the equation for formal charge is the number of valence electrons, which is what the question was asking for, minus the number of non-bonding electrons, minus the number of bonding electrons, divided by 2. Okay, so for oxygen has 6 valence electrons, and there are 4 non-bonding electrons, and since there are 2 bonds to oxygen, we have 4 bonding electrons divided by 2. So the formal charge for the oxygen is equal to 0. So this is the formal charge when it was ionic bonding with the sodium. But a more accurate depiction would be to separate the ions for now. And let's calculate the formal charge when oxygen is not bonded with the nitrogen, or sodium, sorry. So again, it would have 6 valence electrons, 4 non-bonding electrons, but this time there's only 1 bond, so we have 2 bonding electrons divided by 2. So 6 minus 4 minus 1 is 1. And let's do the same thing for the sodium. we can show that the sodium will donate or give its electron to the oxygen, like so. And after it does that, then we can calculate the formal charge after sodium gives one of its electrons. Okay, so now this changes things a bit. Okay, so now the number of non-bonding electrons is 6. And now there are 2 bonds, or 1 bond, and 2 bonding electrons on the oxygen. And this is how we would get -1 as its formal charge in the ionic bond. Okay, so now if we look at the sodium, sodium has 1 valence electron, and there are no lone pairs on the sodium. So we just write 0. And it doesn't, when the bond isn't formed and it just gave one of its electrons, then we also write 0 bonding electrons divided by 2. And this is how sodium gets its positive charge. Okay, so and now they can form an ionic bond because they are oppositely charged. Okay, so now let's look at part B, and probably just fit it here. Which substituent in this has the highest priority? So we have a compound that contains mainly carbons and hydrogens, and they point at the different carbons. But since there's a bromine on substituent 1, this gives it a higher priority. Okay, so in this case, bromine, since it is a substituent that is not carbon, or it has, yeah, it's a substituent that is not carbon or hydrogen, this is why it is the highest priority. If there was an alcohol group on this compound, then the alcohol would have a higher priority than the bromine. But since the bromine's the only one here, then it has the highest priority. Okay, so the junior tutor said there are 6 valence electrons for oxygen when determining formal charge. And for B, to determine the substituent with the highest priority, examine the electrons directly attached to the stereocenter of the compound. A substituent with a higher atomic number will have a higher priority than the substituent with a lower atomic number. If the chains are similar, proceed down the chain until there is a point of difference. In this case, substituent 1 has a bromine atom present. It has a higher atomic number than the carbon atoms present on other substituents. Therefore, substituent 1 has the highest priority. Okay, so the solution is correct.